Welcome to my channel. Let's understand this G Advanced 2013 question. This is one of the physics question. This question says about one object is at this position, it moved to Q and there is a frictional force also involved in it. So question is asked about what is the velocity when it reaches to the point Q and what is the normal force acting on it when it reaches to the point Q. There are two questions associated with this question. Let's understand one by one. Let's find out first the velocity at point Q. I have redrawn this picture again here. So this is the circular path. This is radius r. This is radius r. This height drop here would be h r sin theta. H r sin theta, because this angle is 30 degree. This angle is 30 degree. So 30. This is r. So this will be h r sin theta. So we have to find out, we have to apply certain concept, simple concept, understand the concept. If we are able to apply the simple concept, then we can solve this question. This is very easy question, but if we understand the simple concept properly, so that concept can be used for the solution of the complex problem also. So let's apply the energy conservation law. What energy conservation says about it? Let's understand from there. Energy conservation law. Energy conservation law says that any loss in potential energy will be equal to the gain in kinetic energy if there is only conservative force. But in this case, the question says about, if you look at the question here, this says about there is a work done in overcoming the frictional up to the point Q, as shown in figure below, is 150 joule. So there is a non-conservative force, that is frictional force involved here, and to overcome that non-conservative force, frictional force, the 150 joule is utilized. So this energy conservation law is, we can say that we understand that loss in potential energy, PE I am writing, is equal to gain in kinetic energy. Gain in kinetic energy. So this is applicable there if there is a only conservative force. But here this cannot be applied because some of the loss in potential energy is utilized in countering the frictional force. So this equation can be rewritten as, in the case of non-conservative, that is frictional force, loss in potential energy is equal to gain in kinetic energy plus energy consumed, energy used to counter frictional force. So if we apply this equation, we can get the velocity at point Q. Let's understand how. Loss in potential energy is, this object was here and this datum line here, then there is a drop in height. So this loss in energy, potential energy is mgh. We can write. And gain, suppose initially velocity was vi here, and then when it moves here, this is vf. So this equal to half mv square f minus v square I. And energy utilized in counter frictional force is given 150 joule. So 150 joule. So mgh. Here the mathematics is used, h barabar r sin 30 degree, means mg r sin 30 degree is equal to half m v square f is the velocity at point Q, we remain like this, vf Vi is 0 because initially velocity was 0. This becomes 0 plus 150 joule. So if you solve this, m is equal to 1 kg, it's given here 1 kg, and g is equal to 10 meter per second square, and r is equal to 40. If we put here, so this will 1 into 10 into 40 sin theta half, again half into 1 into v square f plus 150 joule. So if we, this will be at 200, this will take a 150 minus 150 is equal to half v square f. If you calculate this v square f is equal to 100, and so vf is equal to 10 meter per second. So the correct answer is B out here. If you look this question, this asking about the speed of block when it reaches to point Q is 10 meter. This is the B is the correct answer for it. So and we have utilized certain concept, energy conservation law, with non-conservative force, that is frictional force, and we generated the equation and we got the velocity at point Q. The second question is asking about what is the normal force when it reaches to the point Q. So we'll use that. We'll solve the second question, that is about the normal force when the object reaches to the point Q. Every question has will be having certain concept. We to understand the physics is nothing about understanding the concept, applied certain mathematical tool, use that mathematical tool in the concept and get the answer. So again we'll understand what is the concept hidden in the second question to understanding the to finding out this normal force at point Q. So we have to understand what is the force applied out here in point Q. If you look at this point Q, this is the mg force, gravitational force acting on it. This is the mg gravitational force acting on it. If you look at this component, this is mg sine 30 degree, this is mg cos 30 degree, because this angle is 30 degree, and this is the normal force, and this object is moving in a circular motion. So when object moves in a circular motion, so it requires a certain force to keep in the circular motion. The difference between these two forces, that is normal force and mg sine theta, which is the component along the radial direction of the circular motion, will be utilized as a centrifugal force to keep this object in a circular path. So we understand what is the concept we utilize. We have used certain free body diagram. Free body diagram we have drawn there. What are the force applied on the object? Free body diagram is nothing but understanding the force that is being applied on the object. And second concept, we have used circular motion concept vis-a-vis centrifugal force. The centrifugal force is nothing. This force is written as centrifugal force is equal to mv square divided by r. R is the velocity of the object. R, this along this tangential direction, means this velocity, this along this direction v, which we have already observed. and r is the radius of the circular path. So if we draw the equation, means normal force, the part of normal force is being utilized as a centrifugal force, means Lmg sin theta is equal to mv square. This is, if we got it, because this is moving in a circular motion, we have to use this equation. The difference between the normal force and mg sin theta is equal to mv square by r. We have to find this normal force. This question is asked. If you put the value out here, m is 1, g is 10, sin theta is equal to half, again 1, v square we already find out 10, so, and r is 40. So this means n is equal to n is equal to, if we keep this side, mg sin 30 plus mv square by r. M is 1, g is 10 into half plus mv, m1 v square we have already observed in the first question is 10 square divided by 4. So if we solve this, and this 40, r is equal to 40, so this is 5, if this is 2.5, then 7.5 Newton. So normal force, if you look at this question, the question asks a magnitude of normal force that acts on the block at the point Q is nothing but 7.5 Newton. So what the concept utilized in the first question is about energy conservation law. In the second question, we utilize the concept of free body diagram and the centrifugal force. Any circular motion, if the body is in the circular motion, the required force to keep it in the circular motion is mv square by r. And the difference between normal force and this component, mg sin theta, is utilized to keep this object in the circular motion. So we utilize this concept and got the answer. So I hope you understand the concept, and if you understand, so you can utilize this concept in the complex problem also. This is a JEE advanced question, but if I thought I made it very simpler to you.